Hi, and welcome to my demonstration of my load balancer. My name is Rahul Singh. And first, let me take you through the classes for the load balancer. So we'll start with the request class. And this request class has um, four members. So it has the source IP address of the request, the destination IP address, the time that's required to process the request, and then the job type. So P for processing and S for streaming. And then we have a couple of functions, mainly getters and setters, but the get IP in, get IP out, get the processing time, get the job type, and then we have the corresponding setters for those. And next, let's go through the web server class. So in the web server class, well, first, let me just scroll through the implementation of the request. So pretty basic getters and setters. Now we have the web server class. So the web server class has um, the server ID. So this will be like a 1, 2, 3, 4, 5, just to identify the server. And then it has a Boolean value stating whether the server is currently processing a request or not. And then it has a pointer to the request that is being currently processed, and it'll be null pointer if there's none. And then we have a constructor, destructor, and we have the process request function, which provides a request to a server that is free, but if the server is busy, it continues processing the request by decreasing the time in the request for for that server. And then we have a function to return whether the server is free or not, a function to free the server if the current request finishes, and function to return the server's ID, as well as a function to return a pointer to the current request that that server is processing. So this is the implementation for the web server class. And next we have the load balancer class where the most of the work is done. So we have a queue of pending requests and a vector of all the servers that are running. And then we have the current simulation time, um, the available IDs for servers. So let's say we want to remove a server because we want to scale down. Uh, it'll remove a server from the vector of managed servers and add the ID to the available IDs. And the highest ID is um, the next server ID to be assigned from the available IDs. Um, and then we have all the constructor, the destructor, adding a request to the queue, adding a server to the queue of servers or the vector of servers. We can remove a server and this will return true if the server is successfully removed. However, if all the servers are busy when uh, this function tries to re remove a server, then it will not remove the server since all the servers are currently processing a request and it'll return false. And then we have a function to process requests. So this processes the request for this distributes all the requests to the available servers and then advances the simulation time for each server. And then we have the balance load function, which is a helper function to balance the load across the servers. We have the get current time function to get the current simulation time. Um, Generate random requests generates the parameters that specified that amount of requests. So in the beginning of the simulation, it'll generate 100 times however many servers there are. The get servers just returns a reference to the vector of servers. The queue size gets the current size of the request queue, and then get next available ID gets the either the lowest available ID from the set of previously used IDs or generates a new highest ID if no lower IDs are available. So now we have the the main function, and this is where the simulation is run. So this print status, it's to print the status every 50 seconds of all the servers. So it shows whether they're free or whether they're busy, and then it gets the remaining time for each server to complete processing their current request. And you'll see it whenever I run. Um, we also we also add a server if so we have the thresholds here. So if the queue is bigger than 20 requests, then we're going to add a server. If the queue is smaller than 5 requests, then we can remove a server. If more than 80% of all servers are being utilized, then we're going to add a server. And on the other side, if less than 20% of servers are being utilized, then we're going to remove a server. So this is for the dynamic scaling, and that's implemented right here. So if a server is not currently busy, then it'll be removed due to a low load, or a server will be added due to a high load. So let's go ahead and run the program now. So let me go ahead and compile. So I'll first do a smaller simulation time so I can better show you the output, and then I'll show you 10 servers and 10,000 clock cycles in this log.txt file. So we'll start with 10 servers, and we'll just do around 600 seconds for the simulation time. So let's just examine our output here. So first, you can see that the initial request generated is 1,000, which is 100 times the initial web servers. The simulation time is 600 seconds, like we said. The range of processing time for each request is from 1 second to 10 second. So you can see as soon as we started the load balancer simulation, there were 10 servers, and they all took a request from the queue, which was 1,000 servers long. And um, you can see a new request type has been generated right here at time zero. There's a 33% chance of request being generated at any given second. And that's why the request queue size is 991 at the first second, because these 10 servers popped off one and one was created. So it's 991. And you can see server 11 was added due to a high load. So the total servers are now 11. And this continues on. Server 4 will finish processing request. Uh, and then server 4 will start processing a new request once it finished at the next time. And this will continue on until the end, where hopefully I can show you. You can see like now the servers are not currently busy. Every 50 seconds it checks for the scaling check. And if it's under the threshold, it'll get the last server that's not busy and will remove it due to a low load. And so this continues on until the end. And you can see here that the total requests were 1,221, and the completed requests were 1,219. And that's because two of the servers were still busy at the ending time of the simulation. So two of them did not get completed. But you can see servers added were 10, and then 3 servers were removed over the course of the simulation. So we started with 10, and we added 10, and then we removed 3. So we ended up with 17 servers. And yeah, so let me show you that on a bigger scale now in the log.txt file. So here you can, if I go to the bottom, um, you can see it's adding and subtracting servers. So right here, like the server was busy and the queue size was sufficiently big, and so it added a server due to high load, and it continues through this process. But over here, it shows that the total requests were 4,345 and the completed requests for 4,340. Servers added over the course of simulation were 69, servers removed were 77, and it ended with just these two servers. So the final number of servers was two. Thank you for your time, and that's my load balancer.